So guys, question of the day is, how many zeros are there in 130 factorial? Okay, 130 factorial, what is that? That is 1 times 2 times 3 times 4 all the way up to 130. So it's a fuck ton of a number. It is absolutely huge. So, how do we do this? Okay, what does it mean when there is a zero in a number? That means that we can factorize the number as something times 10, an integer times 10, always. And what is a 10? A 10 is a 5 and 2. 5 times 2 is 10. So what are we really looking for here? We are looking for all the ways we can match up a 2 and a 5 such that we get a times 10, which then yields a 0 at the end. So how do we do this? Well, okay, we need to have 2 and 5s. There are a lot more 2s in 130 factorial than there are 5s. So we probably just need to count the 5s, right? So how many 5s are there in 130 factorial? Well, calculating how many numbers there are in numbers in of all the numbers up to 130 are divisible by 5, that's really easy. That would just be 130 divided by 5, which is equal to 26. Which makes sense. What the fuck did I do there? Okay. Divided by 5. So, yeah. I invite so that's 26. And are we done? No, we're not. Of course not, because okay, these are all the numbers which have a 5 in them. They can have more than one 5, right? Well, every number that's divisible by 25 has at least 2 5s in them. So we need to add that also. So, okay, that if we just do the same thing, we would write 130 over 25, but this is not an integer, and we're only counting all the integers that are below 130, so that are divisible by 25, so we need to put a floor on this baddie, and then the answer would be 5, because 25, 50, 75, 100, and 125. And what did I just say there? I said 125. What is 125? 125 is 5 cubed. There's 3 5s in 125. So we do the same thing. We do this, 130 over 125, and this floor, and then we get a 1. Makes sense. And therefore, the sum of these, which gives us 32, is the total amount of 5s there are in 130. And since there are more than 32 2s in 130 factorial, therefore this is our answer. These are all the numbers we have. And this method that we used here actually works for any number factorial. So just for fun, I thought we'd make up a function. I'd call it zeros of n, and then what we mean is that how many zeros are there in n factorial, because how many zeros are there in n is fucking, yeah, that's obvious. So what would that be? Okay, we're taking the sum and we're increasing the power of 5 everywhere. So okay, we can start with our dummy variable. That should be 1, right? Because that's the first one we're doing. And what we had was just n factorial, all of this floor, and then divided by 5 to the power of k. And here, and of course you could extract this in front. This has nothing to do with k. No, sorry. What the fuck am I saying? Of course, no, it's inside the floor. You can't do that. Just kidding. Okay. And what do we need to go up to? Well, okay, so our 5 to the power of k should not be bigger. Well, okay, we can think about it like this. Okay, so we have that. We want to at some point. No, sorry, that doesn't work either. Okay, so we can just say basically that, okay, 5 to the power of k is supposed to be equal to n factorial. No, sorry, n, just n. Yeah. Yeah, there shouldn't be a factorial here either. Damn. Okay, I can think. Well, okay, and this gives us that k is equal to the 5 logarithm of n. And since, okay, what do we actually want here? Well, of course, we want the floor of this, because k has to be an integer, right? So think about this. Okay, so we have that n, which is 130, log 5 is obviously 3.1 or something, and therefore we only went up to 3. So k should be the floor of that. I should end at the floor. Okay, so we have the floor of the 5 logarithm of n. I don't think you can see this, but you hear what I'm saying. So this should be our function with no factorial here, just a normal n. And yes, the sum of 1 to the floor of log 5 of n of the floor of n over 5 to the power of k. So that would be our function for finding how many zeros there are in a number factorial. So yeah, that was everything for me. Hope you enjoyed the video. Have a good one. Bye-bye.